Okay, so I'm starting the recording. So, what's the area formula for a circle? What was that? A equals pi r squared. Is this radius? No, this is diameter. So what do I have to do to get this to be radius? Radius is equal to diameter divided by 2. So then I would say 22 divided by 2 is equal to 11. Now I can use 11. So area is equal to pi times 11 squared. What is 11 squared? What's 11 times 11? I am so glad you didn't say 22. You are correct. It's 121. And I have a pi, and that would be centimeters squared. Now, this would be the exact answer. So on a standardized test, if it says the exact answer, you would use this one. The estimated answer, or rounding to the nearest tenth then, would be to actually use pi. So if I have this up here, I'm going to put pi, because it said that, oh, that was E, that's not pi. Second, pi, there's pi. 121, right? And then press enter. And what would I round this to if it's to the nearest tenth? Be 380.1 or 2? 1. Because this number behind the 1 is less than 5, this is going to be a 1. So it's 380.1 centimeters squared. And this would be the estimated answer, right? Okay, now over here we have yards, we have feet. What is that conversion? How many feet make a yard? 3. Some basic skills test at jobs before you start. Some like construction places make you take a little test. And sometimes they do have conversions on there. So 1 yard is equal to 3 feet, right? And so if I need to convert this to the larger unit, I have to divide by 3. So this would be 3.1 yards. Remember, when you're calculating area, you always want to do your conversions first. It just makes your life easier. So this is 3.1 yards. Where the 90-degree angle is always your height and base. Remember us talking about this? This is an obtuse triangle, so the height's on the outside. So this is height. Which one is my base? 4.7 or 19.8? 4.7. This is base. I do not need this unless I was trying to find perimeter. I'm going to cross that one out because for area, I'm not going to use that one, right? So, what is the formula for a triangle? Area equals divided by 2, or 1/2 base times height. Either way works. It means the same thing. So we know base is 4.7. We know height is what? 3.1. And then I'm dividing by 2. So I'm going to use my handy dandy calculator and I'm going to do the math. 3.1 times 4.7. Okay, when I multiply these two together, I get 14.57. Now I'm going to divide by 2. And I get, what am I going to round this to? Is it going to be 7.2 or 7.3? 3 because the number behind the 2 now is larger than 5. If it's 5 or bigger, we bump this one up. So it's going to be 7.3 yards squared. That's your area. Questions? Are we feeling it all better? Because Thursday you said I went a little fast. So yesterday we spent time going over area slower. Are we feeling better now? Good. Do I want you all going every time you come in my room? No. We want it to be nice and relaxing. Okay. So over here, what shape is this? It's a parallelogram, right? The opposite sides are parallel. For parallelogram, area equals base times height, BH. Where height is where your 90 degree is, and so is base. These two made your height and base. So I'm going to call this height, and where it's drawn to, this is base. Am I going to use this number up here? No. This is yards. This is feet. What do I have to do? I have to divide by 3 to convert it to yards. So what is 20.4 divided by 3? 6.8. And so I'm going to have 6.8 times what? 6.7. And this would equal area. So could someone do that on their calculator and give me the answer? So 45, and what am I going to put for the rounded? 6. Everybody agree? Confirm? And that would be yards what? Yards squared. Very nicely done. I have geniuses, Eileen. Did you see this? I have geniuses in my class. How do I convert millimeters to centimeters? Because it said to convert to a larger unit. Divide by 10. This is base 1. This is trapezoid, right? Or trapezium, if you're used to that word. Did you know that, Eileen? Trapezoid is also called trapezium. Yeah, isn't that nice? So, I have to divide this by 10 to convert it to centimeters. So, height is going to be 5.9. So, base 1 is 3.7. Base 2 is 11.7. Height is 5.9 because they all have to be in centimeters. So I had to convert that height. Now I just substitute in 3.7 plus 11.7 times 5.9, all divided by 2. So, what is it? What is it? 3.7 plus 11.7? 15.4. And then I'm going to multiply it times 5.9. And then I divide by 2, right? So what is area? Area is equal to, what was it? 40? 45.4. And that is rounded correctly, everyone? Oh, good. And this is going to be centimeters squared. Woohoo! We're getting it. Are you silly at home, Eileen? Yes. Okay. So, what shape is this? Trapezoid. But here we're given area, right? So we have to use a little bit of our algebra skills. So 30.3 is area, right? and this is base 1, and this is base 2. That's what I'm looking for. I'm going to make that an x. And then this would be my height. They're all in miles, so I'm okay, right? So it's a trapezoid, so area is equal to base 1 plus base 2 times height divided by 2. I'm going to substitute what I know, and then I'm going to have to do some algebra, right? And all of this is in miles, no conversions needed. So area goes on this side because it is the answer. So 30.3 is on its own. And then I have base 1 is 8 plus x times 5.5 divided by 2. I could clear the fraction by multiplying by 2 on each side. Everybody agree with that? I could either set it up as cross multiplication, or I could just say, oh, if I times 2 on each side, that clears the fraction. What is 30.3 times 2? 60.6 now is equal to 8 plus x times 5.5. And what do I do to both sides first? I want to get rid of this 5.5 by division. So I'm dividing by 5.5 on both sides. I'm running out of room, so sorry. Hopefully you can read it. What is 60.6 divided by 5.5? 11.01 is equal to 8 plus x. Because when I divide, that cancels here, right? And then what do I do to both sides to solve for x? I'm going to subtract 8. And I have to make sure I'm actually rounding to the nearest tenth. Right now it's rounded to the nearest hundredth. What is 11 minus 8? 3.01, but it says here round to the nearest tenth. Tenth is this first place, so it would just be 3. 3.0 or 3. I could put 0.0, right? And this would be miles, not miles squared, just miles, because I was looking for a side length. Oop, can I undo that? Oh, nope, it just turns it around. That's no fun. I wanted to get rid of this weird thing there. There it goes. Miles. Any questions on that one? What type of shape is this next one? I'm going to change. Can I erase this so that way we don't get confused? This is a trapezoid. I ran down to the. Let me erase this. Okay, what type of shape is number 6? It's a rectangle. I kind of heard someone say square. Why isn't it a square? Why is it not a square, number 6? All the sides aren't the same. You can just look right here. Isn't this shorter than this one? Yeah, the definition of a rectangle is 4 right angles. Definition of a square is 4 right angles and 4 congruent sides. So this is rectangle. Rectangle area is equal to length times width. I'm going to call my x the width and this the length. So I have area 17.2 miles squared is equal to area, and I'm substituting 44.9 I'm only showing all the units this time because Miss Connie needs me to do that for ICP. So when I divide by 4.9 miles, divide by 4.9 miles, miles squared over miles just means miles. What is 17.2 divided by 4.9? Which would be 3.5 miles. That'd be the answer for number 6. Right? Okay. So number 7. Find FG. And this is a parallelogram, right? What do we know about opposite sides of parallelograms? They're congruent, right? So if they are congruent, how will I set up the algebra? I set them equal, right? X plus 6 equals 6 plus 2x. And so if I always like to, oh, this is going to be 0 again. I'm going to subtract x, right? I have 6 is equal to 6 plus x. When I subtract x, I just get x is equal to 0. And if x is 0, it wants FG. FG is equal to 0 plus 6, which is equal to 6. Because it didn't just want x, in this case, it said find FG. So, like, I would make this 2 points on a test. 1 point you found x, 1 point you substituted back in to find FG. Right? I don't surprise you on what's on the test. The do nows end up looking like the test, correct? Has anybody noticed that pattern? I just keep adding problems that we've covered. So if you are doing well on your do nows, you should do well on the test. And we'll need to talk because I am not a dictator on when you want your test this week. We're going to talk about that after we go over this. So now, are these opposite or consecutive? Opposite or consecutive? They are opposite. So in parallelograms, what do you know about the opposite angles? They're the same. They are congruent. Because they are congruent, I'm going to do 6x plus 8 equals 8x minus 6. I'm going to draw a long line here. I want to get variables on one side, constants on the other. So if I subtract 6x, I get 8 is equal to 2x minus 6. What do I do to both sides? Add 6. And 2x is equal to 14. And if I divide by 2's, x is equal to 7. And then I'm going to look at the directions and make sure I answered everything. Did they want x? Well, kind of, but they want to know the whole angle x. So we found variable x, but we want this angle measure. So to get that angle measure, we're going to have to, I get more room over here, so I'm going to do it over here. Measure of angle x is equal to 8 times 7 minus 6. What's 8 times 7? Minus 6 is 50. Now, for bonus points, Who is so smart that they can figure out what angle y equals? 180 minus 50 is 130. Because these two have to add up to 180. And then this one's 50. And then this one would be 130. Right? That's how parallelograms work. That the opposite angles have to be equal. The ones that are adjacent, or the word consecutive, they have to have a sum of 180. So if I'm looking at number 9 says find MJ. So this is like a 3-step problem, right? I need to figure out what X is, and then I'm going to have to figure out L, and L and J are exactly the same because they're opposite angles. Make sense or doesn't make sense before I start? So consecutive, what do? I add them together and set it equal to what number? 180. Sounds like you guys learned a little bit of geometry in these past couple of weeks. Have you learned some things? So we're going to combine our like terms. I always do variables first. 5x and 8x is what? What's 5x plus 8x? 13x plus 18 and 19. 37 is equal to 180. And then I subtract 37. This cancels. 13x is equal to 143. And then I'm going to divide by 13. And what is x equals? Okay, but I'm not done because I need angle J. But I know that angle L and angle J have to be equal because it's a parallelogram and opposite angles are equal. So if I find the measure of angle L, I also know that's the same as the measure of angle J, correct? So the measure of angle L is equal to 18 plus 5 times x, which is 11. So 55 plus 18 is equal to what? This is 73 maybe? 73 degrees. So the measure of angle J, you don't know this word, but I'm going to say it anyway because I'm a geometry teacher, due to the oh, wait a minute. I was going to, it's on the top of my lip. Or transitive property. Due to the transitive property in geometry, if L has to equal J and L equals 73, then J has to be 73. Make sense or doesn't make sense? Okay. Transitive property. Transitive property. Okay. Hmm. They want angle G. This is just a quadrilateral. I have no idea if it's a special shape or not. But what do we know about all the angles of a quadrilateral? What should they all add up to? 360. So 17x minus 6 plus 88 plus 12x plus 4 plus 100 has to equal 360. So I'm going to combine my like terms. 17x and 12x is what? 29? 29x. And then I have to add these. Negative 6 and 88 is 82, right? What's 82 plus 4? It's 86, and then plus 100 is 186. You could have done this on your calculator. -6 plus 88 plus 100, right? Equals 360. And now I'm going to subtract 186 on each side. 29x is equal to what? 174. Divide by 29. X has to equal 6. Am I done? I know what x is. X is 6. I am not done because over here it says find the measure of angle G. So I do measure of angle G. G, not 6. Let's make it look like a G, is equal to 12 times 6 plus 4. What's 12 times 6? Plus 4? 76. So the measure of angle G has to equal 76. So over here, an office is needing new carpet. That sounds familiar. Didn't we have an office yesterday needing new carpet? All I did is change the numbers. I did not change the word problem. The office is rectangular with dimensions 18 feet by 12 feet. The carpet costs $16 per square yard. What is the cost? Well, before I calculate area, because the carpet is for square yards, you want to change 18 by 12 into yards. What do I do to change these two into yards? I'm going to divide by 3. Divide by 3, divide by 3, which is what? This is 6 feet times 4 feet. No, not feet now. What is this? Yards. Sharon, you should have corrected me faster. Sharon's usually my editor. What's 6 times 4? 24. So now I have 24 square yards. The cost is $16 per square yard. What do I do with 24 and 16 to find the cost? Multiply. See, you all can become estimators for a carpeting company now. What's 24 times 16? $384? $384. My bedroom needs to be recarpeted, but I have a pretty big bedroom. I think the last time I was estimating it, it was expensive. So right now it's still the yucky carpeting. Okay. Concave. Cave, pushed in, right? Something's pushed in because cave means a hole in the mountain. Convex, everything's pushed out. So 12. Is 12 concave or convex? Convex. Because no push-ins, no dents. My new car gets dented, I'd be very sad. I like my new car. Okay, what's this one? This is the cave, isn't it? So this would be concave because I was pushed in. Cave is like a hole, right, in the mountain. So that's the way to remember it. Okay, we're getting close to the end here. And then we're going to talk about our test this week. Because of spring break, I'm giving you some choices. Okay? N minus 2 times 180. Now look at the directions. I know some of you don't like reading directions. But when you're looking for the sum, you're looking for all angles added together. So it's going to be a fairly big number. How many sides do I have for this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You guys were smart. You went ahead and counted it before I even said anything. So I have 11, and then I multiply that by 180. What's 11 minus 2? And 9 times 180 is, what is 9 times 180? . And that would be degrees because they added every single one of these up, right? And I would get 100 or 1,620 degrees. How many sides is this one? Which one is this one? 12? 12. So if n equals 12, 12 minus 2 times 180 is 10 times 180. Oh, I could do this one in my head. 1800. And we would put a little degree sign. We doing good? Or do I have to slow down? Everybody got 1,800? Good, good, good. Okay, now look at this. What does this say? What does this say, everybody? What does this say? One interior angle, right? And it says it is regular. What does regular mean? Everything is the same, angles and sides. Has anybody ever been to a discount store that sells irregular clothing? Have you ever seen that before? Like at flea markets, sometimes you'll see, oh, this one was irregular. Maybe one of the words, like the letters, are off a little bit. Or maybe one sleeve is bigger than the other. That's irregular if you buy something. Regular would be, oh no, it's cut the way it's supposed to. All size 10s are going to be exactly the same, right? Just to help you remember it. Okay? We good? Okay. So one interior means you divide by n. So pentagon. How many sides is a pentagon? Which one is it? Go ahead, say it louder. You are correct. Good job. So 5 sides. So I just put 5 in here. 5 minus 2 times 180 divided by 5 again, right? So 3 times 180 divided by 5. And I believe, what is that? 70, is it 72 maybe? Oh no. No, it's not 72. 108. The exterior angle is 72. Because together they have to equal what? 180. See how it all fits together? Okay. So this is 108. Everybody agree? 24 gone. That's easy. I didn't have to look that vocabulary up. What's N? N is 24. Eileen, what do you call a dead parrot? What do you call a dead parrot? Polygon. Because poly, parrot, get it? I said it yesterday. Okay, 24, ha ha ha, polygon. Okay, 24 minus 2 times 180 divided by 24. So put that in your handy dandy calculators and give me an answer. Check in your tables, make sure everybody get the same answer. Everybody got the same answer at their tables. Poor Caitlin. Oh no, she has someone over there. I I didn't see him. Hi Montez. How you doing? You're on it. You're gonna give me the answer. So 22 times 180 divided by 24 is what? 165. Oh, we are all what? Geniuses. Okay, Simon, is are these yours? These are what's your older son's name? What is it? Mon? How many sides is a decagon? Uh-oh. Can someone help him out here? So you can learn that new word. Decagon. How many sides? 10. Hey, Mon, how many sides is a decagon? There! You learned something today. So in this case, we're finding exterior. Interior means inside. What does exterior mean? So this is if I extend and it's outside. And here's the formula, right? So 360 divided by 10 is 36. Montez, we all laughed at this word yesterday. Nonagon. Nonagon. How many sides is a nonagon? 9. Mom, can you say nonagon? Yeah, it's 9 sides. Isn't that fun? Not, yeah, non is like 9. So it'd be 360 divided by 9, which is, I could do that in my head, 40 degrees. Okay, so let's talk test. No, talk. Not have test, talk test. I scared them all. I woke you all up though. Anybody who was sleeping was like, what? Okay, so you have 2 choices. We still have one lesson we need to learn, and I'm going to introduce it to you today. I don't know if you'll have enough time to practice. So what we could do is I could introduce the new topic today after you practice interior and exterior angles a little bit more. And then we practice the new material and have review Wednesday. Thursday, test first period. Second period, origami. We put together our ninja stars, Eileen. You like those? Well, you may have to come back on Thursday. Or we could just do a lot of practice tomorrow, review Thursday, first period, test second period. So I'm going to let you all talk, and then you can do a vote. He's going, let's do review and test Thursday. The problem is, if you miss Thursday and don't come in Friday, guess what happens to you? You have a whole week in between off, which makes it difficult. So that's why I was offering test. Well, no, either way would be testing Thursday, wouldn't we? Yeah. So just be careful because and that origami, if we do it, I make it part of your final exam, which is 25% of your grade, but I show you how to do it. So it's all up to you. So Thursday, do you want to review on Wednesday, test first part and then origami, or do you want to just practice a lot tomorrow, review first period, test second period, no origami? I got no origami. Montez has made himself pretty clear. Okay, who wants? Okay, who wants more practice? Raise their hand. So I have 1, 2, 3. More practice, no origami. Montez, you're not gonna get. Okay, who wants to do less practice and origami? Oh, wait a minute here. We have lots of people in our class. Let's try this again. Okay, so our choices, to be clear, and everybody needs to make a choice, is Wednesday. We do a lot of just practice, and then we have a review Thursday, first period, test, second period. Or we do a little bit review. We have tomorrow, test first period, origami, second period. Okay. Okay, so now vote. Do you want no origami. This is for no origami. We're not going to do origami. Raise your hand for no origami and more practice. Test, more practice. Raise your hand. That's what you want. Yes. Okay. How many people is that? 1, 2, 3, 4. Okay, I think origami will build into the review week. You'll still do it, but we'll build into the review week. Okay. That clarified it for me. Okay. Okay, so we area of circles. Can everybody here do an area of a circle? Pi r squared. Everybody good, right? Can we find area of triangles? Area of parallelograms? Area of trapezoids? Okay, we covered a lot of areas. Now we're going to introduce area of regular polygons. It's going to be a new formula and some new definitions. We are also going to need some of that trigonometry or special triangles. You can do trigonometry all the time. Special triangles is supposed to just help you if you can notice it fast. Does that make sense? So you don't have to memorize both. You could just use trigonometry if you want. But let's go ahead and get started. So today's objective is that we're going to be able to find areas of regular polygons. What does regular mean again? Same size, same angles. Very good. And area means how much I cover, right? Okay. Students will be able to apply 30, 60, 90 special triangle patterns and trigonometry. Or you could just stick with the trigonometry because I know most of you liked the trig. But with these, I don't know if we'll get weird square roots or not. Okay, so, but I am going to review. 45, 45, 90. Do you remember what that pattern was? Oops. 45, 45, 90. A square root 2. So that's the pattern for 45, 45, 90s. Two sides are the same, and you take that small side and multiply it by square root 2. Over here, we have 30, 60, 90. What's the, across from the 30 is A square root 3, and 2A, right? Okay, so let's just as review, let's look at this one right here. What is this? Is this 30, 60, 90 or 45? Do you need? Sorry, I thought I put 2 out there. I guess I didn't. Sorry. So this with the 45, 45, 90, A square root 2. This has a square root 2 next to it across from the 90, right? So what's A? A is just 5, right? Because if this is 5 square root 2, and if A square root 2 equals 5 square root 2, if I divide, we just get 5s, right? So this is just 5. You didn't even have to show that work. If you recognize that this was a 45, 45, 90, and across was 5 square root 2, you should have been able just to look at it and to go, oh, 5 and 5, right? That was the goal of teaching these, that we didn't have to always do math, that I could look at a triangle and figure it out fast and easy. So if this is 60 and this is 90, what's this over here? 30, right? Okay. And 30, 60, 90 was A square root 3, 2a. And this time I'm given across from the 2a. So 2a has to equal 16. How do I solve for a? Divide by 2. Now, some of you on your test would have multiplied 16 by 2 and told me it was 32. Then I had to mark it wrong. Because whenever you're given across either the 90 or the 60, you have to solve for a, right? So a is equal to 8. So across from the 30 would just be 8. What would across from the 60 be? 8 square root 3. And that was a long time ago, right? Like last week. We good? I can move on. Okay. Now the other review is trigonometry, right? Sine, cosine, tangent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, or SOHCAHTOA. Remember that? Yeah, this one's not in your notes. We're just doing reviews, but you can take a picture if you need to. Or Eileen, some old hippie caught another hippie. Can I move on? Are we all taking our pictures? That's where I'm heading now to use this. Okay? So here's our trick. We good? We got that? Okay. So I'm on this one. And I remember SOHCAHTOA. So is sine, opposite over adjacent. Ka, cosine equals adjacent. No, opposite over hypotenuse. Uh, adjacent over hypotenuse. Tangent is what? Opposite. Yeah, over adjacent. I accidentally put tangent first. Okay, and this is your degree, right? So the degree we're talking about is 75 degrees. You put your finger on 75 degrees and you label the triangle. What's straight across from the 75 degrees? Opposite. What do I call straight across from the 90? Hypotenuse. And what do I call the leftover one that's not named? Adjacent. So you put your finger on the degree, remember? And we label. Opposite is across from that degree. Hypotenuse is always across from the 90. And then here's adjacent. I don't have a number at adjacent. And I don't have an X. I have 16. I'm looking for X. Which one of these is opposite and hypotenuse? Sine. So it's sine 75 equals 16 over X. And I'm going to place this over 1 and do some cross multiplication. Because sine 75 is just a number stored in your calculator, right? It's a decimal. So if I cross multiply, I get x times sine 75 is equal to 1 times 16, which is 16, because I'm cross multiplying. These two multiply, these two multiply. And to solve for x, I heard it, I have to divide by sine 75. Divide by sine 75. And we talked about a little shortcut. If x is in the denominator, you should know you're dividing. When x is in the numerator, we'll end up multiplying. What's x equal? What's 16 divided by sine 75? Use your calculator. What is it? 16.6? 5, 6, so it's rounded. Yeah. 16.6. And it didn't give us units, so I'm not going to put a unit. Is it coming back to you? And we'll be doing a lot of reviews with these. Okay. Where do I put my finger? On the 48, right? Here's my finger. Now I'm going to label. I'm going across. What's this side? Opposite. And then across from the 90 is hypotenuse. And so what's 15? Adjacent. And so I have adjacent. I'm looking for hypotenuse, so I'm not going to use opposite. So what am I going to use? Cosine. Cosine 48 has to equal 15 over x, adjacent over hypotenuse. I will end up dividing, right? Because x is in the denominator. I like to show my work because I'm a math teacher, but if you want to just divide 15 and cosine, that's fine. Cosine 45, 48, 15. And I divide by cosine 48. So x is equal to what? 15 divided by cosine 48. So what is it? 22. Okay. Did we get rid of those fuzzies? Does it make sense? Okay. Oh, this one's not on there, is it? Oh, this one is? Okay, do this one yourselves, and I'm going to walk around and check your answer. I'm going to write it on my piece of paper since I don't have the answer. Okay, once you got it, raise your hand and let me see your answer. Oh, look at those. The one that's up there. The last one. Who are you? Who are you? Who are you? Very good. So you're going to use tangent. So right, tangent 59. Opposite. Yeah, this is a fraction. Opposite, opposite. Yep, and then cross multiply. Opposite adjacent hypotenuse, so that's correct. But according to the chart, opposite, you have that. This is technically this x, and so you end up just. Anybody else want me to check their work? Very nice. Very good. You get the same answer. That's hypotenuse. You have this one. Because I write on your paper. Adjacent, opposite, opposite, and we have to set up because opposite is x. Okay, did everybody get 28.3? And just because this is getting recorded, I should have paused it, but I didn't. I'm going to write it out. So, opposite, right? Hypotenuse. Adjacent. Adjacent and opposite is tangent, correct? And tangent of theta is equal to opposite over adjacent. I saw a lot of people having this mixed up. They put the x in the bottom, and in this case, it's up on top because opposite is x, adjacent is 17. So it should be tangent. Remember, the degree always goes with the trig function. Tangent 59 has to equal x over 17. When you cross multiply, you get x equals 17 times tangent 59. And you really should put in the calculator this way, just in case you forgot. With mine, I always have to change the degree or the mode because it always reverts on me. But you guys don't have to worry about that. Okay, so 17 times tangent 59, which is 28.3. And this would be a length. So don't put a degree with that. That's how long this is. I don't have a unit because they didn't give me a unit. Okay, that all should have been reviewed. Right? Today is our new. First thing you need to know is what an apothem is. It's not a possum like the yucky creature you see at night. It is an apothegm. The apothegm, do you all want to say that? Apothegm? Apothegm. The apothegm is from the center of a regular polygon, perpendicular. Perpendicular means right angle to the opposite side, right? Anybody confused on what an apothegm looks like? No. Can I move on to the next slide? This is not on your paper. This is a proof of why we use this formula. So, do you see that when I draw an apothegm and I draw from the vertices to the center, that I make a bunch of congruent triangles going all the way around? Do you see that? We're going to use what we know about triangles and a little bit of trig when I'm missing the information I need to calculate the area of a polygon. So this is just a proof of why this works. We're not going to use this method. We are going to use this method. So area is equal to 1/2. What decimal can I use for a half? 0.5. Apothegm times perimeter. And look at beneath that. What's the definition of a perimeter? Side length times the number of sides. Because the sides are each equal, right? To find out the length around the total outside, you just multiply the side length times the number of sides for a perimeter. Have I lost anybody? No? Okay. So, if I know area is equal to 1/2 times apothegm times perimeter, what is the apothegm? What number here is the apothegm? 7.3. It's from the center perpendicular to the opposite side. So the apothegm is 7.3. How do I find perimeter? What's the side length? And how many sides do I have? So how I would do this I would take then 10.6 times 5 to get the perimeter. What is 10.6 times 5? 3 maybe? Go ahead and do that for me. 10.6 times 5. I did that in my head. Aren't you all impressed? Okay, so let me talk about that for a second. Perimeter means all the way around the outside. How many sides did I have here? 1, 2, 3, 4, 5, right? And the side length was 10.6. So 10.6 times 5 equals 53. And that's perimeter. Now I have everything I need to calculate area. Area equals, I don't want to use a half on my calculator. What could I use instead of a half? What decimal? 0.5. I could do 0.5 times, what was the apothegm again? 7.3 times perimeter. What was perimeter? 53. So now use your handy dandy calculator. 0.5 times 7.3 times 53. Oh, wait a minute. I missed something. 7.3 times 53. I don't know. When I clicked it, it must not have clicked the 3. Okay, and when I press enter, I'm done, right? So 193.45. Did it tell me what to, it didn't tell me what to round it to, so I'm just going to write that answer. A is equal to 195.45. Now it's because I'm a 193.45. Oops. That's what happens when my calculator goes away. Unit squared. Okay? I just put unit squared because I don't know what the unit is. When I'm talking about units, is it inches? Is it feet? Is it centimeters? And when we did our project outside, I had students trying to mix their units, right? And then, woo, they got really off. Okay, so over here, I'm gonna try this one. Everybody try this one on their own. I'll be walking around. So over here, A is equal to 7. P is equal to 24.2 times 3. Right? So this was 72.6. Huh? Yeah. I could take you over to Adobe. And so area is equal to, what did I have there? 254.1 units squared. Okay, did everybody get 254.1 units squared? That will do it. Okay. Everybody got 24, 25, 254.1. Okay, now, sometimes we may have to use trigonometry or special triangles to find the apothem, where all they give us is a side length. Okay? To do this, we end up having to cut a triangle in half. I'm going to walk you through the steps. Okay? And I think you have these steps all typed out for you because I am that kind of a teacher. So if you look, see here how all your steps are typed out for you, right? And I'm going to show you how to do this one. So this one's already worked out for you. However, I may open up Paint and 1, 2, 3. Okay, well, I can just do it from here. Number 1, it says to draw a triangle from the vertices to the center of the polygon. So, you see here how I drew a triangle? See here? Okay. Now, I redrew it off to the side because I needed some space to work in that triangle. Does everybody agree I probably needed a little space? Okay, now the height of this triangle, is the apothem. Do you see it? That if I actually drew in the height, that it's the same as the apothem because it has to make a right angle to be a height. And the definition of the apothem is from the center perpendicular to the opposite side. So our goal is to figure out what this apothem is. Everybody agree with that statement? I don't have that length. But because this is a triangle and I have 6, watch what happens. It's a 6-sided figure, right? 1, 2, 3, 4, 5, 6. Doesn't this look like a pinwheel going like around and around? Okay, so each of these triangles are equal. And do you see if I drew it, what does that make? A circle. If you take 360 and divide it by the number of sides, that actually equals this vertex angle. So what is 360 divided by 6? 60. I don't use the whole triangle though. Because I'm looking for this height, I'm actually cutting this triangle in half. What's half of 60? 30. So this mini triangle on the inside here is a 30, 60, 90 triangle. And if this whole length was 16, what's from here to here? What's half of 16? 8. So this is 8. If I remember my 30, 60, 90 triangles, if across from the 30 is 8, then across from the 60 would be 8 square root 3. Across from the 90 would be 16, which makes sense because what's across from all these outsides have to be 16, right? See how math is beautiful? It all works. It's amazing. So this apothem then is 8 square root 3. Once I find the apothem, which I did, I used 30, 60, 90 triangle to find the apothem. And the apothem was 8 square root 3. Perimeter is going to be number of sides times the side length. How many sides did I have? 6. So perimeter is 16 times 6. So then to calculate the area would be 1/2 times apothem, which was 8 square root 3, times perimeter, which is 96. And the steps are all written out for you. And you are allowed to use these guided notes for your test, right? So this would be this is kind of an important thing to make sure you have when you take your test because all the steps are typed out for you. Let's do an example. You have this one on your paper. Okay. Okay, so I'm going to draw right here. I'm drawing this, right? And if this is 6, is this 6 still? 1, 2, 3, 4, 5, 6. Yes. What is 360 divided by 6? 60. So this angle here is what? 60. Now I'm going to draw a bigger triangle so I can work with it over here because I have this pen and sometimes I need to draw big. And I am also going to draw the apothem, right? Okay, now I'll make it straighter. So if this is 60 degrees and I cut the triangle in half, what's this angle right here? 30, right? And if this whole side is 10, what's from here to here? 5. So across from the 30 is 5. Across from the 60 would be a square root 3. A is 5. So what would I write right here? 5 square root 3. 2a, or 90, which we already know is 2 times a, which is 10. And all the outside ones are 10. I didn't need that. Because really all I needed was across from the 60, because this is your apothem, but it's also across from the 60 degrees and is your height. So what's the apothem? 5 square root 3. And I'm going to stop right there to let you digest what I just said, because that was actually quite a bit. I'm going to wait a few, like a minute. You look it over. And make sure you understand why that apothem is 5 square root 3. Can I start, or are you still processing? I can. Does that make sense why the apothem is 5 square root 3? Hmm? Sure. Okay, because remember when we had special triangles, right? And if this is 90, and if this is 30, what would this over here be? 60. Because that whole triangle was, the whole vertex was 60, but remember we're cutting it in half, right? So if I'm cutting this side length in half, then this is 5 here, right? Because across from the 30 would be 5. And then according to our special triangles, that a square root 3, 2a. Across from the 30 is 5. Wherever you see an a, you just substitute it in when you're given across from the 30. So this would be 5 square root 3. So this is 5 square root 3. This is 10, but we already knew that because all the outsides were 10. Make sense now, Simon? Did it make sense? She explained it better? Good. Sharon needs to be a teacher. That's fine with me. So, Sharon, did you explain it? And Simon, are you understanding? Yay or no? Yay? Okay. Now we can move on. Okay. So, what is that's your apothem is 5 square root 3, right? How do I find perimeter? How many sides is this? 6. What's the side length? 10. So it's 10 times what? 6. And we got 6 from the number of sides. 1, 2, 3, 4, 5, 6. Because who wants to go 10 plus 10 plus 10 plus 10 plus 10 plus 10? You don't want to do that. Okay, now I'm going to apply the formula, which area equals 1/2 times apothem times perimeter. And we said, there we go, that I'm going to do this in my calculator, 0.5, right, times 5 square root 3 times, oh, I didn't do that, that's 60, times 60. Well, half of 60 is 30. 30 times 5 is 150 square root 3. If I did it in my head, you could do it on your calculator and get the decimal. What is that? On 0.5 times 5 sec square root 3, don't forget to close your parentheses, times 60 is approximately 259.8. 259.8, right? And it's 150. I'm just making sure all my math was correct. Yes, see? Same thing. Hello. Oh, you're fine. I'm just trying to teach. Okay. They were sitting over here, but yeah. Okay. So now notice I have a separate set of steps, right? Are they all typed on your notes? Other than instead of special triangles, we're going to use trigonometry. And this is an example which you can write your notes down. So I'm going to work with you step by step, okay? So if here's the center and I'm drawing like this, right? Oh, that's ugly. How many sides is this one on your paper? 12. What is 360 divided by 12? 30. But that means the whole triangle, this vertex angle is 30, right? I have to cut the triangle in half because the height of this triangle is the apothem. And I have to find the height of this triangle. What's half of 30? Half of 30 is 15. That's where this 15 came from. I find the vertex angle by dividing by the number of sides. I draw this triangle, but I have to cut everything in half. So 30 divided by 2 is 15. What's 2 divided by 2? 1. So this right triangle on the inside, just this piece right here, this becomes a 90-degree angle because that's the height. And I need apothem to be able to find area. This side is 1. This is 15 degrees up here, right? Now, 15 degrees is not part of our special triangles. We either had 45, 45, 90 or 30, 60, 90. So if this is 15, now I have to use trigonometry. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. If this is my degree, which that's where you put your finger on, what would I label 1 as? It's opposite, because I'm going to the opposite side of the 15 degrees. Put my finger on the right angle, and opposite the right angle, what do I label this as? That's hypotenuse. And then the leftover one I call adjacent. So I have opposite, but I'm looking for adjacent because the adjacent side is the apothem, right? So tangent of 15 degrees has to equal 1 over my apothem, because that's what I'm looking for. When I cross multiply, I get apothem times tangent 15 degrees is equal to what? 1. So I take 1 and divide it by tangent 15 degrees. And what do I get? One. Well, let me check my mode. Then second quit, and I'm going to clear this, right? 1 divided by tangent 15. And what do I get? 3. Okay. Now we're going to talk. I always like talking with you. I'm not going to tell you anything. We're going to have a conversation. So, has anybody ever heard of anything called rounding errors? No? Eileen, have you ever heard of rounding errors? What happen? How do you get rounding errors? You know, do you remember? Okay. It's when you round too early. You really shouldn't round until the very, very end of a problem. If you round too early, your answer on the back of your sheets for checking your answers are going to be off. And I know my class. If you get a wrong answer, what do you all do? It's wrong. What did I do wrong? Well, if you round too early, you will get different answers than the answer key. So you could choose to leave it in your calculator like this, or go out like to 4 decimal places and only round to the very end. So like me, I would probably write this as 3.7321. 3.7321. I'm going to go out pretty far so that in the end, I'm not going to have rounding errors. Oh, all that means. Okay. So this is what? That's the apothem. And probably when I did this, when I rounded to 3.7, right? I'm probably going to get a different answer because I probably just rounded to 3.7. But then I noticed after I made this, that my students would get all upset that their answer didn't look exactly like the one on the back. So we're going to use 3.7321 as my apothem. And my perimeter. The outside was 2 yards. So how much all the way around? How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the number 2 times 12 equals 24. That's perimeter, right? Now you plug everything into the formula. And for no rounding errors, I'm trying to find a nice clean space, area would equal 0.5. I have like a spot on this thing that's not quite working, times my apothem, but I'm going to use this long apothem to avoid rounding errors. And then what was the perimeter? 24. So go ahead, 0.5 times 3.7321 times 24. So see how it's different? And the more correct answer would be the new one, would be 44.78, which we would round to 8. And that would be yards squared. So to get the most exact answer would be just to leave it in the calculator or just go out very far. Because now if I leave it in the calculator, all I could do is just put times again. That is this number, and then I'm going to just put my 0.5 times 24. And that gives me, and see, you had 7, 8. So see how the calculator would be out that far. So just be careful on those rounding errors. Okay. How are we doing? This is a little bit harder, isn't it? Yeah. I would say out of our circle unit gets a little intense and this one. But once you start doing these problems and following the written directions, students are like, oh, this isn't too bad. It's just hard right now because I'm throwing a ton at you. But once you start practicing and you have the steps, you just follow the steps. So let's look at practicing together, right? How many sides is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everybody agree with that? So now I'm going to draw my triangle. And if I draw my apothem, it looks sort of like this. What is 360 divided by 10? Because that's going to give me that vertex angle. And that's 36. So now if I off to the side here, just so I have enough room, I'm going to draw another isosceles triangle with my height drawn in there. And this height is what? What do I call this height? That's the apothem. But I have to cut everything in half. If this was 36 degrees here, what's this angle on the inside? What's 36 divided by 2? 18. So this here is 18. This whole length is 7, right? So what's from here to here? What's half of 7? So this side is 3.5. Now, if I'm trying to find apothem, and this is 18, 3.5 would be opposite. This would be hypotenuse. And the apothem is actually the adjacent side. By the way, you always end up using tangent on these. So, opposite's what I have. Adjacent's what I'm looking for. What's opposite and adjacent? Tangent is equal to opposite over adjacent. So tangent 18 degrees is equal to the opposite side, which is 3.5 over 8. So I cross multiply. A tangent 18 is equal to 3.5. Divide by tangent 18. What does my apothem equal? Three 0.5 divided by tangent 18. I'm going to go out 4 decimal places so I don't get rounding errors. So 10.77, what was it, 19? Oh, 89? So actually this would be rounded up to, well, let me look. Yeah, so 7719. That's what I'm going to put down. So this is tenths, hundredths, thousandths, 10,000ths. Because of the accuracy, I've asked my husband, because, when we're in the hot tub, you talk math. I'm like, what do you round to when you do your work? And he says, at least to the 100,000th. So he goes out one more. Do I? Yes. And Eileen will tell you, we do talk math at home. It's like, yep, they do. Okay. So this is a Potham. Else do I need for this formula? I need P for a perimeter, right? So perimeter is side lengths times the number of sides. So perimeter would be 7 times 10. And what is 7 times 10? 70. Do I have enough now to calculate area? Area equals 0.5 times 10.7719 times 70. And then we can round to the nearest tenth so we don't get rounding errors by rounding way too early. 0.5 times 10.7719 times 70. And I get 30. Now I can round 377.0. 377.0 inches squared. Now y'all are like, I'm glad we voted for extra practice instead of origami. Okay, I want you all, sorry, I'll let you finish that. I want you to try the next one, but we have to talk before, because I'm going to get to the side length really quick. Unless you want to look at the next one while everyone's writing notes and see if you can figure out what the side length would be. Eileen, you did come in on one of the harder days, so for topic wise. Anybody have questions on this one? For the next one, listen, because I'm still waiting for people to get that notes. Your side length for the next one would be 15 divided by what? 5, because there are 5 sides, right? So to get the side length, what is 15 divided by 5? 3. So each side is 3. Now do the exact same steps and try and figure it out. And I got to do my own over here. If you think you got it, raise your hand. Oop. While you're working on that, I'm going to go grab your worksheets. Right? I lose my pen all the time. Don't you think this? Did you have any of your teachers use one of these pen pads when you were in school ever, Eileen? Hmm? No. Isn't that nice though? So I don't have to like be in the way. This is a projector. The old fashioned ones. Yeah, the kind that set the school on fire. Oh. Okay, so for this one, if perimeter is 15 inches, we divide by 5, and we would know that each of these are 3. Right? Okay, now, if I'm thinking about my big triangle and drawing an apothem, this whole angle is 360 divided by 5, which is equal to 72 degrees. And half of that is 36 degrees. So we end up getting this triangle where this is 36 degrees here. This is half of 3, which is 1.5. Opposite apothem. I am looking for the apothem. I have opposite. I'm trying to record so people could at home if they missed it. So this would be tangent of 36 degrees has to equal opposite over adjacent, 1.5 over A, which when I cross multiply and divide, A ends up being 1.5 divided by tangent 36 degrees. And remember, you want to go out 4 decimal places for rounding errors. So 1.5 divided by tangent 36 is 2.0646. 2.0646. That's the height. That's your apothem. Perimeter was given. I didn't have to recalculate it. It's just right here. 15.5 times 2.0646 times 15 gave us approximately, when we round it, no, 15.5 inches squared. Okay, so I gave you some practice.